All right. There's no questions. I'll move on to the second one, which is all right. Y'all have to talk to me now. What rule am I gonna have to use to solve this one? Like, what rule to use for taking derivatives to solve this problem? Correct. Product and chain rule. So product rule is u v prime plus v u prime. So we're going to say u equals sine t squared, v equals cosine of 2t. So u prime equals 2t sine t squared using the chain rule because the box in a box. So you take the derivative of the inside, and that's wrong. And then derivative of this equals negative 2 sine 2t because box, box. All right, so we're going to move down here for this. So u, which is times plus v times
That's not enough.
Yeah, that was loud. What's up, bud? I have my volume really high. And
Oh, you can hear me then, right? No.
yeah.
Oh, oops.
Very good. Two t cosine t squared. Sorry, I keep writing it like this. It's a habit. So simplifying it. Hurry up right here. Negative 2 sine 2t sine t squared. All right. And that whole thing is your answer. So that's a good problem to practice. To practice your trig rules and your chain rule and product rule. Any questions on that before I move on? If not, I'm going to move ahead, solve this problem. All right, so what do we do here? Any suggestions?
You just do the Product rule.
Yeah, you can do product rule. I recommend doing something else first to make your life easier. Yeah, you can take the derivative of each individual piece. But then you're doing product rule once and twice, and you're doing chain rule and all those, and it gets to be a lot. You have a common factor right here, e to the x cubed. So I recommend pulling that out. Simplify always before you solve a problem if you can. Makes your life easier. So now you can use product rule, and it makes your life a lot easier. So u equals e to the x cubed, v equals. What is u prime equal?
3ex cubed.
Close. Remember, if f of x equals e to the u, where u is a function of x.
Oh, it's three.
So it's derivative of u times e to the u. So what's the derivative of x cubed?
It's 3x squared.
Yep. E to the x cubed. And v, this is just power rule. I'll go ahead and do this one. So f prime of x equals e to the x cubed times 18x minus 6 plus 9x squared minus 6x plus 2 times 3x squared times e to the x cubed. Now, we could simplify this. I'm going to let you know right now, it's kind of a waste. Because you don't even have anything, because this will be x squared, will be the highest thing, so you'll just add all that together. So we're just going to call this the final answer. If he asks you on a test, I recommend simplifying this. But, yeah. I did this planning all this, and I did not want to solve that. But do y'all have any questions about this problem, what I did, any of the properties? I'll take that as a no. All right. What rule do we use here?
Chain rule?
Yep. So prime of t, 2 times the original function. So 2 times secant times pi t. What's the derivative of secant? Anyone remember what's the derivative of secant?
I don't know. Secant tan.
Yep. All right. All right, and what's the derivative of pi t? You got to take the derivative of the inside. You can't forget that. To use your variable. So what's the derivative of that? Yep. So this is all multiplied together. These two are the same exact thing. So you end up with 2 pi times secant squared, because they're multiplied together, times tangent pi t. Everyone follow along right there? All right. I'll leave that up while I find a new problem. I think I'm almost done with all the ones I solved. All right. And, oh, this is way harder than it looks. Okay. So, you could distribute this 3t in there, but you have to distribute 3 to the 4th and 2 to the 4th, and that would turn into... Because I did this yesterday, trying to make things easier, and it's not easier. So, you're not really simplifying it by doing that. Sadly. So we're just going to use this, and we're going to use product rule and chain rule. So u equals 3t, u prime equals 3, v equals 2t squared minus 5 to the 4th, v prime equals 4 2t squared minus 5 cubed times 4t, which equals 16t. Let's do t squared minus 5 cubed. So if we're going to plug this in, u, which is 3t, times plus v times u prime, which is just 3. So we can simplify this just a little bit. So 3 times 16 is 48. T squared. That's about as far as you can simplify it. Yeah, I did that. Yeah. Okay. Any questions on this one? It's just a lot of algebra. That's not, if there's no more question. The general power rule, for which question? I'm sorry, I missed that. It didn't notify me. For the one we just solved, Sophia? Yeah, you could use the general power rule if you fold this out 4 times. You see why chain rule gets helpful when you have powers really high? So it get kind of sort of ridiculous. Yeah. So if you do it like that, say f prime of t equals 4 times this cubed times, okay, now what's 162 times 6? That's the problem right there. Y'all aren't allowed to have calculators. And that's yep. I did this way yesterday because I thought it might be easier. Now the numbers get too big if you don't have a calculator. So and this looks a lot nicer too. So I have one more question. I'll go down to the next sheet. This one looks fun, right? Any ideas on how to solve this one? Well, if you do either f of x is f prime of x, yeah, kind of sort of the same thing. So you have, so say f of x equals, over x by there by accident, so I just corrected. So f prime of x equals 2 cosine of x minus 1 times the derivative of the inside, which is just pi, which equals 2 pi. So all you do is you just plug this in front of it and keep everything the same for e. So it's 2 and that's it. Any questions on that one? Yeah. Okay, so cosine squared. Yeah, e cosine inside of cosine. Actually, no, that's wrong, isn't it? That is very wrong. Whoops. Whoops. It's 2 pi. This is wrong over here. Then you take the derivative of cosine. Thank you for catching me on this one. Derivative of cosine is negative sine. I did this right yesterday. I hate getting up early. Times negative sine, because that's the derivative of cosine, times the inside of sine, which is pi. See, they even get me. So negative 2 pi. So that's the derivative of that. This is going to be long, so I'm going to come down one thing. I'll go over this again if you want me to. All right. Any questions on that one, or you want me to go over it again? The derivative of cosine squared, so you got to take the derivative of the outside, so this also equals, I can't write today. Squared. So my box rule, I should have done this. Inside. Take the derivative of the outside. Then this side. Then the inside. So I got 3 derivatives. That's why I should have had a sign. Yeah, I'm about to switch to the quiz now. This is the last question. So, fun fact, I solved the quiz and it messed up earlier and it didn't load the last page, so. I was just trying to go over things. Okay, so for number 1, what type of problem was it? Hang on. I've got to do this. It's tradition now. He went over this at the beginning of class today. I doubt many of us were paying attention that early, but so everything is relating to time. So C of t equals 2 pi r of t. So you take the derivative in respect to time, you get dc dt equals 2 pi dr dt. Make sense? Everyone follow along with that? Yeah, no, the derivative of r isn't 1. If r was the variable, yes. The derivative of r is a function of t, so it's dr dt. But yeah, essentially the r goes away, but you're taking the derivative of it. It's like when you take the derivative of y, just y, you get y prime with implicit. All right. So x and y are functions and functions of variable t. So what is dy dt when x is 2 and y equals 5 and dx dt equals -3? So what you do is you take the derivative implicitly. We've done this before. X and y are both functions. All right. So what do we want? We want y prime. We're searching for y prime. I like y prime because it works faster, or it's easier to write. So that's x prime right there. So negative x prime minus x prime y over x. Does anybody need explanation on how I did that? I'm sorry if I get interference. Okay, so let me come over here where I have my room. So we have x prime y plus x y prime plus x prime equals 0. Is everybody following me to here? I mixed them up. When you take the derivative of x, y, you have the product rule. The derivative of x is x prime, and the derivative of 12 is 0. We good there? I'm going to assume yes. All right. So I'm going to subtract x prime, and we're solving for y prime right here. So leave that alone for now. I'm going to subtract x prime y. So now I'm going to divide by x. No, just write it right there. These drop. We clear now on how I did the algebra. All right. So now you have your values. X prime equals dx dt. So now you have negative 3 minus -3 times y is 5 all over x is 2. So that equals 3 plus 15 over 2 which equals, keep an eye on your signs. Answer is B. Everyone follow me? All we did was plug in the values we had for x, y, and x prime, or dx dt, and solve from there. I'm assuming we're good. Okay, so a company knows that the unit cost, C, and the unit revenue, R, from the production of the sale of X units, so they're functions of X, are calculated by C equals R squared over 122,000 plus 11,397. Find the rate of change of the unit revenue, R, when the cost is changing by $11 per unit. So the unit cost is C. So we want to find dr dx and dc dx is 11. Unit cost is changing by 11. And R in the unit revenue, so R of X, which is just R. I'll just leave it as R, not confuse y'all. R equals 1,000. It's raining, isn't it? Oh, it's pouring outside. So if you take the derivative implicitly, remember C is a function of X. So you'd get dc dx equals dr dx. No, hang on, that's R squared. Equal 2r dr dx times 1 over, and this right here is a constant, so when you take the derivative, it doesn't matter. So now we're looking for dr dt. So solving for this, we have over, yeah, I took the derivative. The hard part about this problem is figuring out through all the words what you need. That's what he was trying to push for this one. So divided by 2r, multiplying by 122,000. So now we have 11, because we have DC, times 122,000 over 2 times 1,000. Well, if you want to simplify, this looks like a lot to do in your head. This 1,000 cancels out these 3 zeros right here. This 2 and this 122 cancels out to 61. So now it just equals 11 times 61, which equals 671. Everybody follow along? And so you got $671 per unit is the unit revenue after cost and everything. Okay, so determine from the graph whether the function of any absolute extreme values on the interval a to v. So are there any absolute extreme values? Correct. It's like that because these are open, not closed. And because they're open and not closed, you can't say that they're absolute. Because up in here, this is a local max and a local min, but they're not absolute. So, got to pay attention to your endpoints always with these questions. Now, this question I didn't like. It said, find the location of the indicated absolute extremum for the function. There is the absolute extremum, but I messed up and it wants the maximum only. So, where's the location of the absolute extremum for the function? You have a point right here where it changes direction, but this is an absolute min. Because that's a min and we're looking for a maximum, we have no maximum because both of these go all the way up to infinity. Oh. But yeah, there was none. I didn't like that right there. You should have just left or said what it was, and I should used to say whatever. But all right, so find the absolute extremum for the values for the function in the given interval. So to do that, you got to find all the critical points, right? What's a critical point, guys? Yeah, when it's zero undefined. Well, I think what you meant to say is, yeah, when the derivative is equal to 0 undefined. So f prime of x equals 2. A derivative will never be 0 undefined, so you don't have any critical points in this one. So all you have to do is check the endpoints. So it has a maximum of 5 at x equals 4, and a minimum of -9 at x equals 3. It's a linear function. That's obvious, I know, but still. And because it never changes direction, there's no critical points. So now we want to find all the critical points. We already said how to find it, so using the basic power rule, now we'll set it equal to 0 to find where it's equal to 0. So at x equals -6 is a critical point. I know I'm moving a little fast, but are we good there? I'm going to assume so. So find the extreme values and where they may occur. So you need the derivative for this, right? There's only one critical point. It didn't give you a domain, and this is continuous throughout the entire function, or throughout the entire domain from -infinity to infinity because it's a polynomial. So it has x equals -1. And because the value on this x squared is positive, that's the a value. So if it was a negative number in front of x squared, there would be a local maximum. But since it's positive, there's going to be a local minimum or an absolute minimum. So now we do y at x equals -1, and we get 1 minus 2 minus 3 equals -4. So the minimum is -4 at x equals -1. Everybody clear there? I just plugged in -1 to the equation, so we didn't have much room. So let's do y is x equals -1 equals -1 squared plus 2 times -1 minus 3. Yeah, which equals 1 minus 2 minus 3 equals -4. Any other questions? All right. So, yeah, he gave you the mean value theorem. So find all values of c. So at what point of x, or what point on the graph satisfies the mean value theorem. So first things first, what you should do lots of times in calculus. What's the first thing we should do? Correct. Take the derivative first. All right. Now what should we do? Yeah, plug in the slip equation. So I'm going to go ahead and find f of -1, and that equals -1 minus 3 plus 1. So -1 minus 3 is -2 plus 1 is -1. And then f of 2, so that's 4 plus 6 plus 1. So that's 10 plus 1 is 11. So now, and right here, we want f prime of c. So the number c, so 2c plus 3. That helps you see, the professor see what you're doing. So come over here, we have 2c plus 3 equals 11 minus -1 over 2 minus -1. So we have the function 2c plus 3 plugged in where f prime of c is, and where f of b, the farthest right, so we plugged in f of 2 minus -1, which is what we got for f -1, over 2b minus a, 2 minus -1. So you end up with 2c plus 3 equals 12 over 3, which equals 4. So subtract 3. So you get 2c equals 1, and c equals 1/2. Everybody follow along what I did there? I just did algebra and solved for c. C is just another variable. All right. So what do we need to happen for this function to satisfy the mean value theorem? What needs to happen? Well, to take a derivative also, doesn't the function need to be continuous? So if the function needs to be continuous, is the cube root of x a continuous function? Yes, continuous and differentiable. Because you can't differentiate points. But is this function, so what does f of x look like? So the cube root of x looks something like this, right? So it's continuous. And if you take the derivative, you can do the limit form to figure it out to see if it actually works. Or you can just do that exists. So you have check and check. Therefore, it's good. And I'm not gonna lie, this is as far as I went. I actually solved this because I got bored. But this didn't show up earlier. So this is all new to me, so be nice. All right, so if f of x equals x to the n, f prime of x equals n x to the n minus 1. So what we're trying to do is undo this. So if f prime of x equals x to the n, f of x equals, we're going to do this, instead of multiplying by n, we're going to do 1 over n plus 1 times x to the n plus 1. Y'all following along? This is extremely important at the end of this course and the end of calculus, and calculus 2. If y'all are going on to calculus 2. This is the main one. Yeah. So what we want to do, so you have x to the 5th, so you do 1 over x to the 5th, 1 over 5 plus 1, which is 6, times x to the 5 plus 1, which is 6. So, and then plus any arbitrary constant, which we name as c. Everyone follow along there? I'll actually do this in blue. Oh, it turns green. That's cool. Any questions over that? For any of those curious? Is equal to the same thing as that. So if you ever see that elongated s, it has something to do with this. I don't know if y'all seen it yet or heard of it. So why is there a constant c? Because you can have say you have x to the 6th, 1 over 6 times x to the 6th minus 57. Isn't the same derivative as 1 over 6 x to the 6th plus 340 or 45? So you can plug in any real number right there and it'll work. Any other questions? I don't understand why he went over this so fast. Did he go over it in class? Because I don't remember him going over that in class. Because that's literally the end of the course. Okay. All right, so use f of x to find any critical points. So we already have the derivative. So what do we do with the derivative? Yep, we're going to set it equal to 0. So since it's already factored for us, like they're so kind, we're going to do x plus 9 equals 0 and x plus 8 equals 0. So this x equals -9 and x equals -8. Those are the x coordinates of your critical point. You worded this question when it says determine critical points. You're supposed to have the function, version of function, to find the derivative, and then plug in these points to find the y coordinate. But he's taking it easy on y'all, I guess, because y'all have limited time. This thing was due at 12:30, right? Because I kind of just gave you 100. Okay, I won't take y'all's word for it. Oh yeah, he did do the first derivative test. That's cool. So what we're gonna do, we're gonna do the same thing right here. So x equals 1, x equals 9. So you have your coordinates. So what I like to do is draw a number line and plot your critical points. You're following me? And so we're going to plug numbers into f prime of x. that are less than 1, in between 1 and 9, and greater than 9. So we're going to do, first we're going to do f prime of 0 equals 1 times 9 equals 9. You don't even have to do 1 times 9, but it's positive. All you care about is that it's positive. We're going to do f prime of 2. We're going to get 1 minus 2, which is negative. So negative times a 9 minus 2, which is positive, which is going to be a negative. So that's negative. And we're going to do f prime of 10. So 1 minus 10 is negative. 9 minus 10, right? Negative. They're both negative, so a negative times a negative is positive, right? So that's positive. So everywhere the derivative, so this represents f prime of x. So everywhere the derivative is positive, it's increasing. Everywhere it's negative, it's decreasing. So it's decreasing between 1 and 9, and increasing between negative infinity to 1, and from 9 to infinity. You don't need me to go over that again and talk through it. Okay. So what I started out doing, we have the derivative, so I set it equal to 0 and found our critical points. Then I plotted the critical points on a number line. All right. All you care about now when you're finding increasing and decreasing is if the answer is positive or negative when you plug in your critical points. You don't even plug in, if you plug in your critical points, you're going to get 0. So you got to plug in something slightly to the left. So let's say f prime of x equals 1 minus x times 9 minus x. So we have 1 here. So we need a number that's less than 1 to plug into the equation. So the easiest number that's less than 1 is 0. So always pick your easiest number. So 1 minus 0 times 9 minus 0 equals a positive number. So you have positive, positive. Positive times positive equals positive. Don't even worry about the sign. Get your positives and negatives. So we're going to do f prime of something else. So now we need a number that's between 1 and 9. Well, you can do 5 or 1 or 1.000005. But I'm going to do 2. So we're going to do 1 minus 2 times 9 minus 2. You have a negative answer, so this would be negative 1, for example, and you have a positive answer, so this would be positive. You'll have a 7. And that negative times a positive equals negative. So right here, I put a negative between 1 and 9, showing that the derivative is negative. The value of the derivative is negative between 1 and 9. And now, we need a number that's greater than 9. I chose 10 because it's generally easier to work with. You can choose 100 if you want to. Equals 1 minus 10 times 9 minus 10. That equals negative. 1 minus 10 is negative. Times 9 minus 10, which is negative. Negative times negative equals positive. Am I making more sense? So right here, I'll put a positive sign. Are y'all with me so far? Okay. And now interpreting this number line, this is the hardest part. So everywhere you have a positive sign, so this is from negative infinity to 1, the main function is increasing. So f of x, f prime of x. This is derivative, not the main function. Everywhere you have a negative sign, so between 1 and 9, it's decreasing. The main function is decreasing. And everywhere you have a positive sign, so like between 9 and infinity, it's increasing again. So this graph is going to look something like It's going to look something like that. Doesn't have to cross the axis or anything, but say this is like 1, starts decreasing around 1 and around 9, starts increasing in and stays increasing forever on. Any more questions about this? I'll take that as no. Oh, decimals, okay. Using an maximum minimum find out on a graphing calculator. I thought y'all weren't allowed to use graphing calculators. Does he know about this question? Did it even pop up for y'all? Y equals clear. Okay, well, I'm gonna put it in a graphing calculator. Actually, no. Yeah, why not? I'll go over the one below, and then I'll go do any of it else. Yeah, that question, yeah. The functions local and absolute extremes, if any, where they occur. So you want the absolute extremes. There's no range on this one, so this is over negative infinity to infinity. So we start out, as always, almost, take the derivative. Now you want to set it equal to 0, so I would pull out a negative 3 times x squared minus x minus 12 So you have a negative sign right here, so that means both your answers are different. And this is negative, so you want the negative to be larger than the smaller one. So now you have critical points. X equals negative 3 and 4. Y'all follow along? Any questions on this one? So now that you have your critical points, you go back up to the original equation. You have f, and you plug in your critical points to find your local mins and max. So f negative 3 equals negative times negative 3 cubed plus 1.5 times negative 3 squared plus 36 times negative 3 plus 2. This is a doozy. Equals negative 3 cubed is negative 27. So negative times negative, so it's 27 plus 1.5 times negative 3 squared, so it's 1.5 times 9. So it's 27 over 2. We'll do this. Plus 36 times negative 3, which is actually a minus. $108 plus 2. This doesn't seem right. Oh, wait. It is right. He just didn't put the values right here, but you still have to solve for all this. Which equals 65.5. So, and then we're going to do f of 4 negative 4 cubed plus 1.5 times 4 squared. And to save y'all the trouble, I'm putting in a calculator because I'm lazy. 106. So at f of 4, yeah, I plugged in f negative 3 equals that, and f of 4 equals that. Following along? Okay. So we know that it's negative. That's why I was throwing me off. That's probably why I was throwing you off. So we know that there's a minimum at f of negative 3. So at x equals negative 3, there's a local minimum. There's a local maximum at x equals 4. So 106. So there's a maximum at x equals 4 and a minimum of negative 3 at x equals negative 3. Bam. All right. Any questions? Of the last one? Okay. So first things first, we found the derivative of the main function. You want, when you're reading the question, it wants to know the function's local and absolute extreme values, if any. So because this is not on a closed domain and it continues from negative infinity to infinity, there are no local extreme values. I mean, no absolutes. So if it goes to infinity either way, there's no absolutes. So there's only local. So you want to find f prime of x. So f prime of x, you find the derivative. Once you find the derivative, you want to know the critical points, because that's where you find your local extrema. So to find your critical points, you set the equation equal to 0. And what I did here is I just factored out of negative 3. That changed the sign of the x of everything. Took out a negative 3. And then sorry about that. I guess it's stuck around too long. Is it still recording? Can y'all see it now? Okay. So I set the derivative equal to 0 after I took the derivative, and I factored. And you set x plus 3 equal to 0 and x minus 4 equal to 0, and you get your critical points for the x values. And once you do that, you plug the critical points back into the original equation. That's very important. The original equation to find the location of the critical points. Are we good there? So when you plug it into the original equation, we get negative 3. F of negative 3 is negative 65.5. And f of 4 is 106. So this is obviously less than 106, and that's an extrema. So you know it's changing directions. So you know there's a local max at 106 because that's greater. Are you wondering about how to tell if it's a local min or a local max? Okay. We can go back to our good old number line. So if we plug in f prime of negative 5 to, I would just use this equation right here. Hang on, let's just rewrite a derivative. F prime of x, use the factored version always, equals negative 3 times x plus 3 times x minus 4. Yeah. We're going to do f prime of negative 5, seems like the easiest, equals negative 3 times negative 5 plus 3 times negative 5 minus 4. That equals negative times negative 5 plus 3. We're not even going to do that. A negative times negative 5 plus 3, a negative times negative 5 minus 4, negative, which equals negative times negative equals positive, positive times negative equals negative. So I'm subtracting over here. Now, you only do that to find the location of the critical points. And I did all that for no reason in this equation. He didn't want y'all to actually do that, and I didn't notice that. It's just my intuition. And I'll show you in a second what he was meaning for you to do. So we're going to do now, we're going to do what's between 3 and 4. We're going to do 0. 0 equals negative 3 times 0 plus 3 times 0 minus 4. So that equals negative times positive times negative. Negative times positive is negative. Negative times negative equals positive. So it's increasing right here between negative 3 and 4. Now we're going to need something greater than 4, so I'm going to do f5. So equals negative 3 times 5 plus 3 times 5 minus 4. That equals negative times positive times 5 minus 4, positive, equals a negative. Now, how do you know you have local extremum? Whenever you switch from a decreasing to an increasing, that means the graph is going like, I'll just erase it later. So if you have this, it's going, can y'all see my screen still? Okay. When you have negative to a positive, that means your graph's coming down, 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 and then it's going to shift to go positive. So, it's not always local. But whenever you're going from negative to positive, that means a minimum. And when you're going from positive to negative, so you're increasing on the left, and at some point, you start decreasing again. So it's ugly anyways. All right, so positive and negative means you have a maximum. See how it's increasing and it starts decreasing? That means there's a maximum. When it's decreasing and it starts increasing, that means there's a minimum. So you didn't have to do all this up here, although you can come by the same realization. You can just do that. Make sense? Any questions? Am I making sense? The domain. Say like, since this is from negative infinity to infinity, there's no like, say if this is between 5 or negative 5 and 7, You have to plug in the endpoints. You have to plug in the endpoints and your critical points to the original equation to see which one's the local max and min. That's why I automatically just adjusted to plugging those values in. Force a habit. But since he didn't give you that, you only have to worry about the critical points because that's from negative infinity to infinity. If anything approaches infinity, you don't have any absolute. I guess global means absolute. So these are only local. So you got to pay attention to your domains. Any other questions? You want me to go over another question or anything like that? And that one. It wants you to plug it into a calculator. I mean, you want me to go to Desmos? Oh, the steps? Oh, the steps are the same as number 15. It's just the calculator does it for you. I mean, personally, I don't want to solve that for 0. I'm just being honest here. If you look at these answers, they're in the decimals, but it's the same exact steps. You start out by taking the derivative. So this is from negative infinity to infinity. But you take the derivative, and once you take the derivative, you set it equal to 0, find your critical points, and then do the number line. That's it. And then you find where it's increasing and decreasing and make your assessments best of. See right here, it's going from positive to negative. So since it's going from positive to negative, there's a local max because it's increasing and then starts decreasing. And then right here, it's decreasing and then it starts increasing. Does that make sense? Or okay, yeah, it's the same exact process. Eventually, y'all are going to be sketching graphs, which I'll learn the second derivative test. Any other questions? There's this thing called the second derivative test. So you have to get to that yet, but it'll tell you the concavity of the curve. And you know that. You'll know when it's shifting the curve and how this curve is going to be shaped. So you'll be able to sketch it, but you won't be able to get the exact values like a computer will. But yeah. So any more questions? That's going to be Wednesday probably. He's going to go over that. If there's no other questions, I mean, I will see you guys Wednesday if y'all stop by.